So hello learner, once again I welcome on the class of Geotechnical Engineering. So I hope you all are safe and doing well. So in the previous class we have seen about the relative density. We have seen the expression of relative density in terms of void ratio and dry unit weight. And after that I have discussed about the consistency of clay and the Atterberg limits. So in Atterberg limits we have seen the four stages, that is solid stage, semi-solid stage, plastic stage and liquid stage. So today I will discuss about the liquid limit, what is the definition of liquid limit and how do we compute the liquid limit in the laboratory, and after that I will discuss about the plastic limit of the soil. So today I will discuss about the liquid limit. Liquid limit, it is denoted by small w. So firstly I will write the definition. So it is the minimum water content, it is the minimum water content at which soil is still in liquid stage. So it is the minimum water content at which soil is still in liquid stage. At liquid limit, soil has very less shear strength of soil, very less shear strength, approximately 2.7 kilonewton per meter square, which is negligible. Liquid limit, liquid limit can be computed in the laboratory using Casagrande device. Casagrande tool. So liquid limit device or liquid limit device or can be calculated by the device called Casagrande device, given by A. Casagrande, a geotechnical scientist, which has given the device, and on the name of his scientist, the device is called Casagrande device. So apparatus used for the determination of liquid limit is Casagrande tool, IS 425 micron sieve, grooving tool, spatula, oven, tin can, weighing machine. oven. So these are the devices used for the uh, to determine the liquid limit. Casagrande tool, IS4 25 micron sieve, grooving tool, spatula, oven, tin can, weighing machine, oven, evaporating dish, evaporating dish. So these are the apparatus required for the determining of liquid limit. So this is the Casagrande liquid limit apparatus. This is the handle. Handle is rotated at the 2 revolution per second, and this is called brass cup. And this is the number of blows you can either manually counted, or there is a record. You can see from here how many blows are there. This is the nut. So, and this is the rubber pad, and this is the 425 micron sieve. Similarly, the grooving tool, there are two types of grooving tool. The first one is ASTM grooving tool, and the second one is Casagrande grooving tool. So what is the difference between this ASTM grooving tool and Casagrande grooving tool? So the bottom width of the so the bottom width of Casagrande tool is 2 mm, and the top width is 11 mm, and the width is 8 mm. Depth is 8 mm. And in the ASTM tool, the bottom width is 2 mm, and the top width is 13.6, and depth is 10 mm. Similarly, this is the spatula and thermostatically electric oven. So what is the procedure to compute? So there are two types of grooving tool. There are two types of grooving tool: Casagrande grooving tool and ASTM grooving tool. So Casagrande grooving tool, 2 mm bottom width and 11 mm top width and 8 mm depth. Similarly, in STM grouping tool, so the 2 mm bottom width, 13.6 mm top width and 10 mm depth. So these are the specification of the grooving tool. So the selection of grooving tool that depends on the type of soil. Selection of grooving tool depends on the type of soil. Soil has low plasticity. Generally, we preferred ASTM grooving tool. So what is the procedure? So about 120 gram of soil sample is taken and add water to make a paste. With the help of a spatula and in the evaporating dish, put the 120 gram soil sample and add water of normal consistency and mix, make a soil paste. And this paste is put into the brass cup, and with the help of grooving tool, the entire paste is divided into two parts, and after that rotate the handle at a revolution of 2 revolution per second until it will come closer to each other, and at that time you have to count the number of blows, and the about 10 gram of soil sample is taken from uh, the soil which is comes closer, and compute the moisture content by oven drying methods. So you have two readings, two observation, at least 4 to 5 observation you have to take in, and the number of blows should be in the range of 10 to 40. So if I write the procedure, so about 120 gram of soil sample is taken and add water to make soil paste. Put the soil paste into brass cup, and with the help of grooving tool, cut it equal parts. Rotate the handle 2 revolution per second until it will comes closer. Record the number of blows and take some soil sample for the determination of moisture content. Repeat the same procedure. Repeat the same procedure by adding the water in the same soil paste, and read the value of number of blows and water content. 4 to 5 readings is taken, and number of blows should be in the range of 10 to 40. So observation table if you make, so number of blows and water content. The number of blows N1, let us assume W1, N2, W2, N3, W3, N4, W4, N5, W5. Once you have make the you have taken the observation, So with the help of this observation, draw a graph between number of blows in on the x-axis log scale and water content on the y-axis normal scale. This graph or curve is called flow curve. So flow curve is the graphical representation of number of blows on the x-axis log scale and the water content on the y-axis normal scale. So if you make the graph, this is water content, number of blows. So a graph like that. These are the observations you have taken. So this is flow curve. This is log scale, and this is the normal curve. So if you take the at 25 blows, the water content can be read on the y-axis, and that water content is called liquid limit. So from the graph, this is the graph, water content versus number of blows, and this is the curve. So at 25 blows, let us assume this is n is equal to 25, read the value of liquid limit. So at 25 blows, this curve is called flow curve, and at 25 blows, the water content is called liquid limit. So what is flow index? Next heading is flow index, IF. Flow index is defined as it is the slope of flow curve. So slope of flow curve, if I draw the flow curve, this is water content, this is number of blows, log scale, this is the flow curve. So slope of flow curve. So let us assume this is this value is W1, this is N1, W1, and this is W2, N2. So the slope of this curve. So let us assume this is theta. So IF is equal to, we can write Flow index is slope of this flow curve. So we can write W1 minus W2 divided by log 10 N2 by N1. So this is the value of flow index. Higher the value of flow index, lower will be the shear strength of soil. Flow curve. So tan theta we can write W1 minus W2 divided by log 10 N2 by N1. So higher the value of, we can write higher the value of flow index, lower will be the shear strength of soil. And we have seen the expression of slope. IF is the slope of flow curve, and we can write W1 minus W2 divided by log 10 N2 by N1. So this is our flow index. So dear student, today I have discussed about the how to compute the liquid limit, and with the help of Casagrande liquid limit device, we have seen the how to compute the liquid limit. And after that, I have discussed the what is flow curve. So flow curve is the graphical representation between the number of blows on the x-axis in log scale and the water content on the y-axis in the normal scale. And after that, I have discussed about the flow index. So flow index is the slope of flow curve, and higher will be the flow index, lower will be the shear strength of the soil. And the expression of flow index, that is equal to the slope of flow curve, we can write W1 minus W2 divided by log 10 N2 by N1, where W1 is the moisture content at N1 number of blows and W2 is the moisture content at N2 number of blows. So in the next class, I will discuss about the how to compute the plastic limit, what is the definition of plastic limit, and after that the definition of shrinkage limit, and how do we perform the shrinkage limit experiment in the laboratory. So take care of your health and happy learning.